Lookups on two-dimensional arrays in Excel can be quite challenging, as they require you to look up both a row and a column number to return. In this video, we'll walk through three different methodologies to accomplish this task: an index match match and two variations of the XLookup formula.
In our example, we'll be walking through an exercise to look up discounts for each individual store and product. So on our left, we have a list of store numbers, products, for individual transactions that were completed by a fictitious paint company. On our right, we have a number of discounts for each store and each product. For example, store 1 received a 43% discount on product A, 50% discount on product B, with different discounts for each store and each product. We want to pull in the discount into our transaction database so we can ultimately calculate what is the net revenue from the transaction. How would we do that? I'm going to walk through three different methodologies for accomplishing this. One will be an index match match, and then two different variations of using an XLookup. First, our index match. You may be familiar with this, but index, you want to highlight your array, F4 to lock that in place. Use a match to identify your row number. You will match your store number to the store number in your lookup table. F4 to lock that in place, 0 for an exact match, and then use another match to identify your column number. Your lookup value will be your product in your transaction database. Your lookup array will be your product in your lookup table. F4 to lock that in place, exact match, and you can fill that down and you have the discount for each one of your transactions. If I use the evaluate formula tool on cell G2, I can look and I can see I've done a match on A2, which is store 75, which tells me to return the 75th row in my lookup table, and then a match on product A, which tells me to return the first column in my lookup table. And then my index simply returns the 75th row and the first column in my table. So if I highlight 75 rows and one column, I can see it returns 41%, exactly what we get in our index match. So if we wanted to use an XLookup, this is something I've actually candidly found a little bit challenging. So let's talk about how we could do this with the base XLookup formula. What I'm actually going to do is I'm going to manipulate this data set. So if I use a pivot table, I can drop a pivot table on my existing worksheet. And what I can do is I can drag the store number into my rows, and then I can drag my different products into my value section. If you bear with me, what I've done here is I've just recreated this table, right? I have the store number and then I have the sum of my different products across my columns. But if I drag this sigma values variable into my rows, now what I have is a long data format compared to a wide data format, right? I have a single value column with multiple variables in the same column. While this format is obviously challenging to work with, what I could do is go to my design tab. I could go to report layout and show this in tabular form, and then go to report layout, repeat all item labels. And now what I have is the store number and the sum of product A for every single one of my stores. So I have a distinct row for every single one of my store numbers and every single one of my products. So it makes it really, really easy to use an XLookup, or honestly even a VLOOKUP or a singular index match. I could write XLookup, as that has quickly become my preference, and my lookup value will be my store number, and then I'll use an ampersand to select multiple criteria. And then I will use a concat formula to make my product the sum of space, the product that transaction represents. I'll close my formula, and now my lookup array will be my first lookup array, which is my store number, F4 to lock that in place, and then ampersand my second lookup array, which is my product, F4 to lock that in place, and then finally my return array will be the discounts in my lookup table, F4, and now if I hit OK, I can fill that down, and I've returned the same exact thing as using my index match. I won't walk through the evaluate formula on this, but all I've done is an XLookup with multiple criteria. So I have checked both the store number and the product against two different lookup arrays. So that's two ways to do it. I will mention the methodology we just walked through does require you to manipulate your source data, which I have typically found is not best practice. So let's talk about how you can do this with an XLookup while leaving your lookup table in its original format. what I'm going to use is I'm going to use an offset formula. If I write XLookup, my lookup value will just be my store number. My lookup array will be my store number in my lookup table, F4 to lock that in place, and then my return array, for now I'll just put as my first column, so product A, F4 to lock that in place. All I've done is I have 41% because our first product is product A. If I fill that down, you can see that's not right because it's only looking at the first column. So how would we go about shifting our return array to look up on the appropriate column for the product? What I've found to be the most efficient way to do this is to use the offset formula. So if I put offset, my reference will be this first column. I don't want to move it any rows, so I'll put 0. And then for my columns, what I need to do is dynamically identify which column I need to move my return array into. So if I use a match formula, my lookup value can be the product. For my first row, it's product A. And then my lookup array can be the product headers in my lookup table. F4 to lock that in place, 0 for an exact match. And then I'll just subtract 1 as our return array is in the first column. So I don't want product A to return 1 and shift it over 1. If I hit OK, I can fill that down. And now I have the same exact thing as my two other methodologies. So I'll pull up the evaluate formula tool on our second row, row 3, to walk you through how this formula works. So Alt-MV will give you the evaluate formula tool. What I've done is a XLookup on store 55, and then done a match of B3, which is product E, on L4 through Q4. So the product headers in my lookup table. That has returned 5, as product E is the 5th column in my lookup table. I've subtracted 1 so that my offset will move my return array 4 columns to the right. Now my XLookup is looking up store 55 on my lookup array, which remains K5 through K104, my store numbers in my lookup table. But now it's returning P5 through P104, which is the discounts for product E, resulting in 69% for this specific product. So we've walked through 3 different ways to perform a two-dimensional lookup. Personally, my preference would be to either use method 1 or method 3. I find the index match is probably the more intuitive option, where the XLookup, including the offset, can be slightly tricky if you're less familiar with using offsets. I would recommend you don't manipulate your source data into a different format, as that can create unnecessary burden when you need to refresh or update your analysis.